Welcome to this session, and in this particular session we'll be discussing with freshwater ecosystem and green infrastructure. Well, now when we try to understand this particular topic, then let us start from what is ecosystem. Then we'll move on to freshwater ecosystem. And then we'll be able to appreciate better why we are talking of green infrastructure. And then what kind of green infrastructure we need to apply for maintaining our freshwater ecosystem. What is its importance? So that way we will proceed in this particular session. And let's first move to what we actually understand by system. Before going to ecosystem, let us understand what we mean by system. So as you can see, then in system, there always be a input, okay? That input will be there. This can be in different form. That input will go to the system that we are showing in the black box, okay? Now, what is actually system? Say we are talking about education system, we talk about legal system. Similarly, we talk about, say, hydrological system, online system. So different kind of system words we use. But then suppose this item, that we never call as a system. So what exactly we call as a system is that where different component act together to perform a certain objective. So that's what is the system, or to achieve a certain goal. Objective may be multiple objective also there, but then what is our goal? To achieve that, different component acts together, then we call it as a system. And with action of all these different components, finally it will give some output. So this is what, when we have a kind of things that we call as a system, and when there is an output, that output can again influence our input. In that case, just like this, in this case we call this as a closed loop system. That means our input is being done something with the input, then it is giving an output, and whatever output is coming, that has a feedback to the input. So that way it is a closed loop system. But sometimes what is that, whatever input is given, output we are getting, and then output is never influencing the input, then we call that as a open loop system. Okay. Now with this very basic concept of system, now we'll try to see what we mean by ecosystem. Okay. Well, now that ecosystem, when we are talking about that, these terms are probably familiar to all of us, that ecology, ecosystem, and then need of balancing this ecosystem. First, let us understand the term ecosystem or ecology. The ecology term is basically coming from the Greek word oikos, which means, as you can see, oikos means the house, and the logos. Logos means the pattern or the study of the pattern. That means what we are studying in ecology, that basically is ecology refer to study of dwelling places. So that is what our ecology. And then when we come to ecosystem, that is when different components of living and non-living things. Why we are talking about this thing? Because when we are saying it is a dwelling place, study of the dwelling place is ecology. Who are the dwellers? So dwellers is not just human being. All flora, fauna, whatever is there, plant, animal, human being, all are the living element. This is our dwelling place. And then we are interacting with the various, it may not be all biotic, there may be other component where we are interacting with, and these components like river, hills, whatever it is. So all these are basically our dwelling place, and dwellers we all are. And that's why when these are the different components, and when all these different components of living and non-living things interact together and maintain a balance, okay, generally in ecosystem they always remain in a balance position. Okay. Now when some external forces, that is, it can be, natural force, or it can be anthropogenic force. That anthropogenic force means our activity. So because of our activities or by natural forcing, if that balance get disturbed, then it takes long time, or it may take long time to come back to its again original balance position, or to reach a different balance position. And that's why we are now becoming more concerned, because when the ecosystem we are disturbing, and if it goes to another balance position, that may not be very advantageous for the human being, because the reason is that it may try to balance by removing, if our activities is becoming very detrimental to the nature, then it may be working like that, that it is trying to remove some of the human being. That means a lot of death may come in. So that's why we are becoming more concerned that our ecosystem remain balanced in a sustainable way for a long time. So that's what is our concern, and that's why we are more and more concerned about this ecosystem. Now there can be different ecosystem. Now what is freshwater ecosystem and why this is so important? Now if we see that freshwater, it is actually a very, very precious commodity on the planet. You see that one wrong idea I would like to say, that from our childhood, maybe it is with you also, when we went to the school, we were told that 2/3 of the globe is filled with water and only 1/3 is filled with land. So we always think that land is very precious. Even fighting and everything is for land, not for water so far. The reason is this one, because we understand that water is abundant, 2/3 is covered with water. But is it actually that 2/3 water is useful for us? That is what is a very serious topic that we need to think about. Information is not wrong, but we need to think it from different viewpoint. So that's why I'm just bringing this particular slide, though things are already known to many of us, all of us rather, that when we talk about water, actually 2/3 of the globe is filled with water, that is fine, but out of these, the fresh water is only 2.59%, that is 2.6% around. Ocean, it contains 97.41%. And when the water is in ocean, it is saline water, we cannot use that for our day-to-day use or for our various use. There are of course technology to convert the saline water to fresh water, but it's a very costly technology. And for our general purpose, we cannot have that kind of technology applied to have our all fresh water. So that fresh water which is available is just 2.59%. So then out of this fresh water, you can see the ready water which we can use is just 0.014%. And because why it is? Because most of the water is in the ice cap and in the glacier. 1.984% is in the glacier. And within the soil also, not the groundwater I am not talking about, but then groundwater is there. Groundwater is basically your 0.592%. So when we try to get the groundwater, again lot of energy is required for pumping. So this is another concern. Ice cap and glacier, we cannot get it directly. Now of course melting of glacier is becoming another concern, but then readily usable water is only just 0.014%. But out of these, how much is in the lake? It is 0.007%. And in the river, by seeing all this, we think that a lot of waters are there in the river, but it is not, only 0.001%. And in our biota, that is with plant and animal, it is 0.0001% again. And in atmosphere, rather, it is better. It is 0.001% is in the atmosphere. And within the soil, that means, no, I'm not here not talking about the groundwater, just but in the soil pores also we have sufficient amount of water. This is 0.005%. So this is the distribution of actual water availability, and that's why, is it that 2/3 of the globe is filled with water and we have enough water? It is definitely not. It is just 0.014% which is ready water available for us. Now, where from this water come? It comes from the rainfall and the snowfall. So we must be very careful about this precious commodity that is coming from the rain and the snowfall, of course. And so where we should keep this precious commodity? Nature made a very well balanced things. When the raindrop comes, what happened to it, how it moves, and this natural balance was very fine. But then now with our activity, we have deteriorated that balanced situation, and that's why we should be more careful now to rectify that one. In that context, we are talking about green infrastructure. Okay, let us just see what was the nature's way of carrying this rainwater to its useful niche. Niche means home or house, we can talk about. So niche of precious raindrops. When it falls on the earth's surface, initially it will be falling onto the plant, trees and all these things. So on the leaf it will be falling, and a part of that water will be evaporated back to the atmosphere, and that we call as a abstraction or initial abstraction. So after abstraction, whatever is left, a part of that water will be coming as a surface water. It will be flowing over the surface, and when it is flowing over the surface, part is infiltrating into the groundwater. Over the surface there will be pores, so it will be infiltrating into the ground or below the surface to enrich the soil moisture and to enrich the groundwater. That way, this is the process that it is going over there. And then so after whatever is left, that is again flowing to the river and lake. But before flowing to the river and lake, there will be retention, because there are several low-lying area, pond kind of thing, depression kind of things on the earth's surface. So that part gets stored, a part of water gets stored here in a natural form, and this is what is called retention. So what it means that when raindrop is coming, a part is going back to the atmosphere, part is infiltrating into the ground, and then part is stored in the depression, and then it is moving to the river and lake. So the river getting, and river dimensions of the river where from in long run get generated in that form. So it can carry the water. Sometimes of course flood was there in case of exceptional rainfall, but nowadays what is happening, that because of our activity, again there is connection from river, it will go to the groundwater, and from groundwater also sometimes water emerge into the river or lake, and then finally all these moves to the ocean. Rivers also directly flow to the ocean. The issue is that when it reaches the ocean, then intentionally I am using the red color. That means it is not a usable water. So our concern is that if we can keep our water in this part by various green infrastructure, then it is very useful for us. So that's what is the concern. And now what is happening, that as we are causing a lot of deforestation, so in absence of this forest, the initial abstraction is going off. So this is reducing. That's why our surface runoff is increasing. And then depression, storage, whatever was there, pond or low-lying area, that we are filling up, wetland kind of thing, that we are filling up for our various activities. Because as I said that we consider land to be very costly or the most precious, so we are filling up those and we are using this for land. That's why this initial retention is going up. So more and more water is coming to the river and the lake, river getting flooded. Again, it is getting stored in some part of the surface, causing water logging and all this issue. And then we are making our surface paved. Courtyards are paved, roads are paved. So what is happening, that infiltration, chance of infiltration is going down. And the grass we are removing, so water is moving quickly over the surface, so infiltration time is also less. So that infiltration component is reducing. Now when this infiltration component gets reduced, our soil moisture is depleting, and So infiltration component reduction is another issue. Also, what is happening as we are making the surface paved, so a lot of pollution is coming from that, and so our river is also becoming polluted, okay? And then our groundwater is depleting. All these are causing several problems as the rivers are getting more and more, and then of course some part is evaporated into the atmosphere, some part through evapotranspiration, some part is going off. And as when more and more water is coming to the river, then what is happening that we have flood problem, we have waterlogging problem, and as I have mentioned that surface are paved, lot of industries are coming, all surface water are carrying a lot of pollution into the rivers and the lake. And then as the soil moisture is going down and the groundwater is reducing, so what is happening? We have poor agriculture. We need to put more effort. And if we try to pull the groundwater up, then we require more power need. So these are some of the adverse situations when we go for this kind of things. And the impact of climate change now, again, the spatio-temporal availability of rainwater is becoming another serious issue, because that we are finding that rainfall is changing. Rainfall is changing. We are not going into the details of this climate change impact now in this particular discussion, but yet the rainfall is changing, but we are having now high intensity rainfall. Somewhere rainfall, total annual rainfall is increasing by, will be increasing a little bit. Somewhere it will be decreasing, say 3 to some percentage, around 25%. Our study in different part of the globe is showing like that. But then our number of dry days also increasing. That means if our dry days more, then longer dry spell means it is drought kind of things. And it means when the total rainfall is increasing or it is remaining almost same, but then in that case what is happening? High intensity rainfall will be coming, that is heavy downpour is happening in a short time. This causes flood, erosion, riverbank erosion, flood, surface erosion, so many other things are happening. So that's why we should be more concerned, and if we can take this rainfall, if we can guide this rainfall to proper niche, which is proper places, that is what, that if we talk in our religion, suppose water has a different value, okay? Like every religion, if you see, every religion, Hindu religion if you see, we talk about purity of Ganga river, we talk about our devata, Borun devata, that's why I am talking it as a Borun, boon of orienting rainwater to usefulness. If we can orient our rainfall to proper place, that is what is our God actually, nothing else. So like as I said that if you go to the Islam, then Zamzam water, that is a very pure water and that is of high value. Then similarly in Christian, holy water, dipping into the holy water is considered as the most holiest thing. So like that, water in our culture, in our Indian culture or over the globe itself, it has a different value, but we are forgetting is because we are considering 2/3 of globe is filled with water and we are not caring for that. So that's why we need to be more careful, and we have seen that there are all interaction between different components. So where the niche can be, if we create some retention structure, if we create some retention, this can be natural retention also that we need to promote. That's why a lot of green infrastructure will be coming, lake we need to maintain, then soil moisture we need to increase, groundwater should be more and more, and that's why we should have perforated things so that things goes to the groundwater. We should not completely block that part. So those are the activities that we need to do. Now, with this introduction, how we can do it and what we need to do, I am talking about some bioremediation for water pollution abatement. It is not only water pollution, we are emphasizing on this pollution, but then quantity aspect is also equally important, or rather more important even. Nowadays our concern towards quality is increasing, but then quantity aspect is also, both quantity and quality we need to be very much careful about. So we collectively, whatever measures we take, that we collectively calling as ecological management practice, EMP. We were advocating that term from long back, 10 years back we were advocating that we should talk about ecological management practice, EMP. We always talk about BMP, fine, it is a best management practice, but for what? best management practice for what? So that is another concern. So what we are saying that what is best is that if we take care of the ecological aspect, then we call it as the ecological management practice, and that's why we are talking in this particular term. For example, suppose for a drain of flood, suppose drain, lot of sediments are coming to the drain in urban setup, then someone may say that okay, as the sediment is creating problem, we'll stop the sediment completely, we'll pave all the hill slopes, or we'll do something all the hill slopes so that zero sediment come. But then zero sediment coming is also not good for the ecological balance. Sediment, finer sediment, nutrient bearing sediment has a role to play in the downstream ecosystem. So we are not supposed to make it zero, and that's why for a particular purpose something may be best, but that may not be best for the ecological concern. So if we allow the finer sediment to flow with the water, and then this nutrient bearing sediment is not even getting deposited into the drain, so it will be flowing off to the downstream, to some lake, to some wetland, and that will be serving the purpose whatever is necessary for that particular ecosystem. And that way we are talking about ecological management practice, and in that we use all green measures, okay, like forest. As I have said, what is the role of forest? If we do not have forest, there is a problem. So what is the role of forest? That we all know. Grass, it will stop the erosion. Then in good urban setup, for aesthetic view, we can have garden. Even when we talk about grass cover, there are so many varieties of grass covers are there. Some grass cover give aesthetic beauty, so but then it maintenance is slightly difficult. So that way we can go for optimal combination of these kind of varieties, which will give us, or which will release the required amount of water to the downstream, required amount of sediment to the downstream, at the same time storing whatever is necessary for our living. So that way, this kind of combination we design, and that we call as an optimal ecological management practice. And apart from this, other vegetative method for erosion control that can also come. Then perforated pavement. As we said that we need to have water infiltrate into the ground. So rather than giving a pavement, blocking the road or blocking a courtyard, if we give perforated pavement, which we also call as grass block sometime. So different part of the world, it has different name, but basic objective is that water should infiltrate into the ground. So that kind of perforated pavement or perforated block we need to use, so that we can have a balanced ecosystem and can solve our problem. Then soil and water conservation in agriculture. Agriculture we cannot avoid. There are many forest ground we are converting to agriculture. But then if we do not maintain, if we do not look into the protection of the fertile surface soil, then our productivity of the agricultural land will also go down. This is in the field, and that soil will go down and it will block the river, it will make the river shallow, and the flood problem will also increase. So there can be different combinations of measures like bunding, terracing, and different kind of things can be there, which can be taken up or which need to be taken up for soil and water conservation in agricultural field. Similarly, soil and water conservation in urban area. Now, in most of the urban area, we are facing serious problem of flood, particularly if it is surrounded by hill, then all water falling into the, because for construction of our house, we sometimes cut the slope in a way that it is releasing a lot of sediment into it, and that way we are facing a serious problem in that. So to maintain this thing, different measures we take, and those are coming all under ecological management practice. Then biofuels, and then infiltration trends. These are basically biofuels are linear trends kind of things. In a slope, suppose we are making a linear trends across this, or it is basically a natural waterway we can say. But then when we are filling up these things, we are making something there, we need to maintain a trends there, where we can, there can be vegetated soils also, where basically water is flowing and we are keeping some vegetation there, which can clarify or which can clear the pollution of the water. because some vegetation has the capacity to intake the pollutant from it. So it will be moving slowly, getting time to expose to the sunlight also. It is necessary for so maintaining all these, and then it is getting time, it is infiltrating into the ground, because the in bioswales this the bottom is not paved, it is not a drain like that, it is not a concrete drain, so it will be infiltrating into the ground, and so amount of water is increasing in the soil which is desired, and amount of water on the surface which can cause flooding is not, this is also reducing. So both are desired things. So that way this serves this kind of things. Similarly, infiltration trends, it's suppose drain or trends, even if it is made concrete, but then bottom part we can put perforated block, and then it become that drain portion is also providing infiltration. So that way this is another advantageous measures that we can take. Then sustainable pond, that I will be coming in detail a little bit, because pond is known to all, but we design a pond which is very much sustainable. It is working as a flood cushioning, that is flood control measures. It is solving the problem of waterlogging. I will be coming to that. This is another. Then rainwater harvesting. In fact, in a sustainable pond also we can do rainwater harvesting, or any other method of rainwater harvestings are welcome. Injection well, that is also a component of our sustainable pond, but this rain injection well, that can put the water into the ground or deep into the aquifer. But the more concern is that, one concern what we are talking about is that when we are infiltrating it into the ground, then we should be careful that we do not inject polluted water into the ground, because that ecosystem will be affected very badly. Okay, so I'll be coming to that again. So these are some of the measures. Then biofilter from stormwater, for stormwater pollutants, like if we use some biomaterial like say pebbles or boulders or wood even sometimes, or sediment, sand kind of things, or any biomaterial if we are using, and when the surface water is moving over that, then what is happening, the water is getting filtered automatically. So naturally it is getting filtered. In fact, I would like to give you some example from northeastern part of India. In the hilly terrain, I am not sure whether this is in the Uttarakhand or in other places, but then in Mizoram and in some other places I have seen, this is called tuikhu. That means the surface water that infiltrate on the top of the hill. Okay, this is infiltrating into the ground and it is flowing through the hills and at bottom of the hill. That means at bottom somewhere, suppose the road is there, in the bottom of the hill we make a small opening, and there that water get collected. As it is passing through a very long vertical path, the water get filtered, and that water was tested, and then it was found that it is carrying all good quality of good water. So that's why it is very, very advantageous to have this kind of, that is what that biofilter naturally also we are having. Similarly, we can talk about constructed wetland. As we understand that wetland has the capacity of clearing the pollutant. Sometimes nutrients are more, if it is, then also it is a pollutant. If it is not required, if it is beyond the capacity, then it become a pollutant. And in wetland, this kind of vegetation automatically come which can uptake the additional nutrients, and that's why the pollution get reduced. So the nutrient pollution get reduced. So that capacity is there in the natural wetland. So following that, the people, when we have this kind of situation from an urban area, suppose a lot of phosphorus, nitrogen, this kind of things are coming, or from the farming area things are coming, then people construct wetland just following the principles of natural wetland, and then that we call as a constructed wetland to purify our flowing water, and that is another advantage we have, one kind of green structure. Then finally we are talking about green building, because urbanization we cannot avoid. Okay, the urbanization will always be there. It is increasing. It will be because all advantages are there in urban place. But then question is that what kind of urbanization we need to have? That is what is important. And when we have some urbanization method, in that if we have the building component, and this building, if it is designed as a green building, means it is not disturbing the ecology, it is not using high energy, so that kind of concept is being utilized, then that we call as a green building. Okay, and that green building I will be discussing more, of course, and that way these are all different bioremediation for water quantity management as well as water pollution abatement. Okay, so with this I am coming to this particular point, that what next is that freshwater ecosystem. Well, why we are talking it in terms of freshwater ecosystem? That's the very basic point, that already we have understood what is system, what is ecosystem, and now we are coming to freshwater ecosystem. And then we have also in between we have discussed what are the different green measures or green structures that we can use for managing our water design. So when we talk about freshwater ecosystem, it is basically the biotic and abiotic components that affect freshwater or get affected by the freshwater form the freshwater ecosystem. So suppose any biotic component that is affected by the freshwater, any form of freshwater, or like forest or sand, this kind of things which are abiotic component, which get affected by the freshwater, or those things which also affect the freshwater. Combining all these things, there is an interaction between all this that we call as a freshwater ecosystem. So both quantity and quality, as I am emphasizing, of water is important. So as such, when we say it's a ecosystem or freshwater ecosystem, streams, lakes, reservoir, wetlands, ponds, groundwater, and then sediment in it, and their interaction with all flora, fauna, whatever it is in that whole ecosystem, including microorganism. Because people sometimes forget to think about the microorganism. In the soil, there are a lot of small microorganisms which help us in our agriculture, but sometimes it can affect adversely also. So these things also a important component of our ecosystem. And then virus. Now, of course, people appreciate this virus, but before this situation, probably people didn't think about this, though this is between the living and non-living kind of things. But then this is extremely important, and also human being. Now, why we are talking about human being? I am putting a question mark. In many definitions, this human being is not put, because we are defining the thing. We think that this is ours, but it is not like that. We are there in. That's why human being, because our anthropogenic activity actually disturbs the entire thing. So we'll have to consider ourselves as an integral part of the ecosystem. So human being is not apart from nature, it is a part of the nature. So that's why I am including human being also. And all these things makes the broad boundary of the freshwater ecosystem. Earlier we were talking about system boundary. So this is what is the broad boundary of freshwater ecosystem. And what is the major input to this system? That is sunlight and its derivatives like temperature, wind, out, and what can be the output? Rainfall will also be coming there. And what is the output? Output from this ecosystem can be different ecosystem services. Like what kind of benefit we get from all this ecosystem for our living concern, including the freshness of our mind. If we travel to near a lake, if we walk along a river, the freshness that we get, it rejuvenates our whole activities. So those things are also considered as the ecosystem services. How to get the value or quantify these things is a